Sine of A is opposite over hypotenuse, which is B over C. Cosine of A is equal to the adjacent over hypotenuse, A over C. Now if I look at angle B, sine of B is opposite over hypotenuse, A over C. Cosine of B is adjacent over the hypotenuse, which is B over C. Now if I look here at the sine of A and the cosine of B, they're the same thing. Sine of A is equal to B over C. Cosine of B is also equal to B over C. We'll just leave it like that. And that's because they're both referring to the same sides. The opposite of A for the cosine is B over C. The cosine of angle B is referring to the adjacent side. So they're both the same ratio. And that is called the complementary angle theorem, because both of these angles equal 90 degrees. So it's easy to get the other given one angle. The complementary angle theorem is written out like this. Sine of an angle theta is equal to cosine of 90 degrees minus theta. And that is because if I'm given, let's say, angle A, since both of these angles must equal 90 degrees, I can subtract this angle from 90 to get angle B, and then when I take the cosine of it, it's the same thing. And similarly, when I do the cosine of an angle theta, then it's equal to sine 90 degrees minus theta. And if I want it in radians, then I would just do pi over 2, and then theta would be in radians, but I'm just doing it in degrees for now. So if I take the cosine of A, that is equal to the sine of B. And I'm going to know B if I have A, because I would just subtract A from 90 and I would have angle B. Or if I had B, I would just subtract B from 90 and I would have A. There's also a complementary angle for tangent. Tangent of, let's say, A is equal to opposite over adjacent, B over A. Tangent of B is equal to opposite of adjacent, A over B. Now, this is pretty easy as well. I just think of what would be the opposite, and that would be cotangent. If I take the cotangent of A, this is equal to the adjacent over the opposite, which is A over B. Cotangent of B, adjacent over opposite, B over A. And I see that the tangent of A is equal to B over A, which is equal to the cotangent of B. So tangent is complementary with cotangent. Tangent of theta is equal to cotangent 90 degrees minus theta. And if I wanted secant and cosecant, then I would just do the inverse of these. So for sine, it would be the cosecant is equal to the secant of 90 minus theta. For cosine, if I did the inverse, it would be the secant is equal to the cosecant of 90 minus theta, and then for tangent, it would be the cotangent is equal to tangent of 90 minus theta. Pretty simple, no need to go into detail and write them all out.